ಅನುದಿನ ಅನುಕ್ಷಣ ಮನೆಯಲ್ಲೂ ಕಲಿಯೋಣ, ಕಲಿಕೆಯ ಹೊಸ ಹಾದಿಯಲಿ ಜೊತೆಗೂಡಿ ಹೆಜ್ಜೆಯ ಹಾಕೋಣ, ಸಂತಸದಿ ಕಲಿಯೋಣ ನಮ್ಮ ಹೆಮ್ಮೆಯ ಈ ಕ್ಲಾಸಿನಲ್ಲಿ.
Yes sir. Yes teacher. Present ma'am.
Namaste children, welcome to Samveda e-learning program. Today in the topic electricity, we are discussing the fifth part, which is the subunit heating effect of electric current. Already in the previous 4 sessions we have learned basic concepts in electricity, Ohm's law and factors on which resistance of a conductor depends, and resistances in series and parallel. Today we are learning about the subunit heating effect of electric current. Yes children, I think you have recalled this electrical appliances. What is this? This is an electrical iron box. So what is happening there? What is the principle that this electrical iron box is working on? Can you name that effect?
Children, you are observing this electrical equipment. I think you are very familiar with this. What is this? Yes, you are right. This is an electrical hair dryer. We use this to dry our hairs when they are wet. This is electrical iron box. This is electric kettle. Here we pour in cold water, and by providing electricity we get hot water out of it. Yes, I am sure you have got the right answer. This is a soldering gun which is used to solder small electronic components in electronic circuits. So this works on the principle of using electrical energy and then converting it into heat energy.
So children, just now you had a look at that activity. So can you name any more electrical appliances which work on this heating effect of electrical current? Yes, what is this? This is a electrical heater. So children, I think, what is the reason that these electrical appliances produce more heat, whereas the other electrical appliances like television or fan and all these appliances, they do not produce that much amount of heat? What is the reason here? Yes, I am sure you have thought the right answer. Here, as you can see, this wire has turned red. The reason is it has the temperature of the wire is very high. So as soon as the electrical current flows through this wire, the resistance of the wire, that is this wire, it puts across a huge amount of resistance to the flow of electrons. So the electrons cannot easily pass through this wire. So what happens there? The electrons, they collide with the neighboring atoms and they are attracted by the neighboring atoms as well. Because of these collisions, the amount of heat generated is more in these sorts of wires. But if you take a wire which is having a lower resistance, then it will not get red. That means it will not get heated up so easily. So the reason for the wires getting heated or the metal getting heated or the conductor getting heated is the resistance of the conductor, because of which more number of charges collide and more amount of heat energy is produced. As you can see, if the electrical circuit is purely resistive, that means if we connected more number of resistances to the battery, then the source of energy, that is the electrical energy that we are supplying, it continuously gets converted in the form of heat.
Children, this is an experiment to demonstrate heating effect of electric current. Here we make use of the items female micro USB pin and 2 crocodile clips which are connected with each other, and a graphite lead, and also 2 candles. Through this experiment we will verify that when electric current is passed through the graphite lead, whether it will have any change on its temperature. Now we are taking the crocodile clips and connecting the 2 crocodile clips to the ends of the graphite lead. As you can see, the graphite lead is placed on the candle. Now we are connecting it to the electric power. The connection is made. Now electrons are flowing through graphite. As you know, graphite is a good conductor of electricity. So free electrons are moving through the graphite lead, but these electrons, they collide with the atoms. So now just observe what happens. Yes, what are you observing? The candle is melting. That means the graphite lead is hot. What is the reason? Yes, it is because of the more number of collisions of electrons with the atoms, that is the resistance is more. Therefore heat energy is more produced here. This is what we call as heating effect of electric current.
In order to move any object, we know in science that some amount of work has to be done. So we already know that whenever the work is done or whenever we apply a force on any object, if there is a displacement, then we say the work has been done. Work is equal to force into displacement. But here in the topic electricity, we are not talking about mechanical work. What we are talking about is the work done by the potential difference. So potential difference is the one which does the work to move the charges Q. So it is applying the force V, that is potential difference is the force, and it is moving the charges Q. Q amount of charges are moving because of the potential difference V. So the total work done here is W is equal to V into Q. That means potential difference into the charge, total charge is the work done. Children, can you define power? Yes, power is the rate of doing work. That means we calculate the amount of work with respect to time. So here what is the amount of work that we are talking about? Yes, it is V into Q. That means the work done by the electrical current, and with respect to time, that means V into Q by T. So here Q by T, you already know that it is the value of electric current. That means Q is the number of charges or the total amount of charges passing through a point with respect to unit time, then we call it as electrical current. So in place of Q by T, we have substituted I. As you can see, P is equal to V into I. So the rate of work done by electrical energy is called as electrical power. The total work done, V into Q is equal to P into T. So what we can substitute in place of P is V into I. So the total amount of energy supplied in time T is V into I into T. Remember this, the total amount of electrical energy supplied in time T is V into I into T. As I earlier said, when you are considering a circuit with resistors, whatever electrical energy is supplied to the circuit, what will happen to it? Yes, you have the right answer, I think. The electrical energy, when it is flowing through the resistors, more amount of collisions result in more amount of heat. That means if you supply more amount of electrical energy, that is V into I into T, which we just saw, the total amount of electrical energy is V into I into T, more amount of electrical energy will result in more amount of heat that is being produced, as it is a circuit with resistances. So now the entire electrical energy will get converted into heat energy or will get dissipated into heat energy. So, we can say that V into I into T, that is the total electrical energy, is nothing but the heat energy, because entire electrical energy is getting converted into heat. So, hence the term H. H is the heat energy produced because of the electrical energy supplied to the circuit. And here on the right hand side you can see we have written IR into I into T. IR is the equation by Ohm's law, that means V is equal to IR. So, we have substituted in place of V, we have substituted IR and into I into T. So, what will we get here? I into I is I square and R T. This is what we call as Joule's law of heating. Now, based on the Joule's law of heating, what are the things that we can derive? Yes, there are three things that we can derive, or we can also say that the amount of heat produced in an electrical circuit, it depends on three important factors. Which are those factors? I think you should remember that equation, H is equal to I squared RT, right. So, that means I is electrical current. So, for a steady current I, the heat energy produced H in time t in the circuit is directly proportional to I square, that means to the square of the electric current. What else does the heat energy produced depends on? Yes, you are right. The second factor on which the heat energy produced in any circuit depends on is the resistance of the conductor. So, the amount of heat produced in a resistor in time t is directly proportional to the resistance of the conductor. That means, if resistance is more, then the heat energy produced in such a circuit will be more. In the same way, the third factor where the heat energy produced depends on is the time on which, or the time for which the electric current is flowing through the circuit. That means, if you are using a television for 10 minutes, then the amount of heat energy produced will be lesser than if you use the same television for 1 hour, or if you switch on the iron box for 1 minute and if you allow for another 5 minutes, then you will observe that the heat energy is more, because the time for which the electrical current flowing through it is more. So, children, these are the three very important factors on which the heat energy produced in any electrical circuit depends on, which is given by the Joule's law of heating. Now, let us try to solve a problem based on this Joule's law of heating. Here you need to observe 100 joule of heat is produced in each second in a 4 ohm resistance. So, 100 joule is the heat. So, the symbol we use is H for heat, 100 joule. Resistance R is equal to 4 ohm and the time is each second, means 1 second. And what we need to find? Find the potential difference across the resistor. So, V is what we have to find. Already you saw through the Joule's law of heating that H is equal to I squared RT was the equation. Now, here we need to find the potential difference, but to find the potential difference we know the formula IR. Here resistance value is given, but I is not there. So, electrical current we need to find its value by making use of the substitution like this, by transposing I is equal to root H by RT, the same equation H is equal to I squared RT. If we try to separate I in that equation, we get in this form. Now, if we substitute the value of H, that is 100 joule, and the value of R, that is 4 ohm, and the value of T, that is 1 second, we are getting 4 into 25 times is 100. So, square root of 25 is 5, that is electrical current is 5 ampere. Now, V is equal to IR. If we substitute the value of I as 5 ampere, we get it is 20 volt. So, the potential difference is 20 volt. Children, now you have learned how the amount of heat energy produced depends on various factors in any electrical appliance. Can you recall in the earlier you had mentioned some electrical appliances which work on the heating effect of electrical current. That means they use electrical energy and produce heat energy. As you can see, electrical iron and electrical toaster, electrical oven, electrical kettle. So, all these are devices which work on the same Joule's law of heating. So, here these are the practical applications of Joule's law of heating or the heating effect of electric current. The reason for these appliances produce higher temperature is their resistances. We use such conductors where the resistance is high to produce more amount of heat energy. And what is this? This is an electric kettle. Again, here it uses the electrical energy to produce more amount of heat because its resistance is higher. And children, here you know this bulb also functions on the heating effect of electricity. Which is the part in the bulb which gets heated up? Yes, you are right, it is the filament. And you must be knowing that the filament has a very high melting point, that is 3380 degrees Celsius. So, they use metals which have a high melting point because we do not want the filament to melt very easily. Therefore, melting point should be higher in filament bulb. In order to prolong the life of the filament, it has to be isolated as much as possible by using an insulating material. So, therefore, they use nitrogen and argon gases which prolong the life of the electric bulb or the life of the filament. Children, there is one more interesting application of heating effect of electric current. In order to find out, come let us have a look at this activity.
Children, I am asking a question here. Have you seen this very important equipment? Yes, this is a fuse. Now, do you know there is a wire inside it? Yes. What is it made of? Yes, you are right. It is made of tin and lead alloy. What is the purpose of using this wire? There must be some very important purpose. Now, to understand it, let us see this activity. What are you seeing here on your screen? Yes, we have a tin lead wire and also we have a soldering gun. I think you have seen in electrical repair shops. So, what will happen now? Yes, you are right, children. As soon as we bring the soldering gun near to the wire, that is tin lead wire, you just observe, now it is touching. So, it is in which state? The tin lead wire is in solid state, but after it is getting heated up, it is turning into which state? It is turning into liquid drops and falling on the table, as you can see. So, this wire is melting, that is changing its state from solid to liquid. This temperature is called as the melting point at which this solid changes into liquid state. For tin lead alloy, the temperature is 183 degrees Celsius. Usually, alloys have a low melting point, children, and they have a high resistance also. So, remember, alloys have a low melting point and a high resistance. Now, we shall see whether it will have the same impact on the copper wire. What do you think? Copper is a metal. Let us see. Now, I am bringing the soldering gun near to it. Yes, we are not observing any sort of melting here. So, what should be the melting point of this metal copper? Yes, it is very high. That is why it is not melting at this temperature. Children, copper has a melting point of 1080 degrees Celsius. So remember that alloys have a low melting point. Now, will this knowledge have any application in the fuse? Yes, already you may have got the answer. Yes, in the fuse also the wire used is tin lead wire, which is an alloy. It is having a low melting point. When we use the fuse at homes in high voltage, this wire melts. Because of the high voltage, the heat energy melts the wire as it is already having a lower melting point. Fuse is covered by porcelain. Why do we need this? So, this porcelain acts as insulator.
The fuse will avoid the flow of electrical current to the device. So, remember, the fuse is always connected in series. And one more thing you need to remember here, in fuse the wire is made up of alloy, tin lead alloy. Why do they use alloys? Yes, one important property of alloys is they have higher resistances than metals. Also, these alloys have a lower melting point. Now the question, why is porcelain used around the fuse wire? Yes, children, you are right. It is acting as an insulator so that we can use that for having a grip of the fuse and making a proper connection. Insulator avoids the flow of electrical current and avoids the shock. The fuses that we use are 1 ampere, 2 ampere, 3 ampere, 5 ampere and 10 ampere, etc. For example, if you are using an electrical iron box of and 1 kilowatt electric power, then you can see 1 kilowatt divided by 220, that means it is P by V, that means it gives you the current, because P is equal to VI 4.54 amperes. So, this electrical iron box we need to use a 5 ampere fuse. Children, earlier you saw electrical power means rate of doing work by making use of electrical energy. So, here the rate at which electrical energy is consumed or dissipated is called as electric power. As you can see, P is equal to VI, that means is equal to I squared R. V means IR by Ohm's law. So, IR into I means I squared R, and also the power can be symbolized as V squared by R. Why? Because I means V by R by Ohm's law. So, V square by R square, if we substitute R and R gets cancelled, we get V squared by R. P is equal to V squared by R. The SI unit of electrical power is watt. That means it is the power consumed by a device that carries 1 ampere of current when it is operated at 1 volt of potential difference. As you can see, P is equal to VI. If the power is 1 watt, that means the potential difference is 1 volt and electrical current is 1 ampere. So, 1 watt is equal to 1 volt into 1 ampere. In the same way, we use 1 watt is a smaller unit. So, 1000 watt is a bigger unit, which we call as 1 kilowatt. Now, if you use 1 kilowatt of electrical power for 1 hour, that is what we call as 1 kilowatt hour. That means 1000 joules of electrical power each second for 1 hour. 1 hour means 3600 seconds, 60 seconds for 60 minutes. So, we get the value 3.6 into 10 to the power of 6 joules. So, this is the value of 1 kilowatt hour. This unit is what we call as units for domestic electrical use. In electrical billing, this kWh or kilowatt hour is what we call as unit. 1 unit means 3.6 into 10 to the power of 6 joules of electrical energy is used.
Children, now let us see what is the electrical power of different electrical appliances. Let us take one by one. I think you have seen this hair dryer. There is 1200 W written on it. It is the electrical power of this hair dryer. That means in 1 second it will use 1200 joules of electrical energy. And also this is an iron box, electrical iron box. Now we shall see what is the electrical power of this electrical iron box. Yes, as you can see, 1000 W is written there. That means this appliance uses 1000 joules of electrical energy in 1 second. So in all appliances you should observe that the amount of electrical energy used is written on it. This electrical kettle, this has an electrical power of, as you can see, 1500 watt. That means in 1 second it is using 1500 joules of electrical energy.
Try to solve a problem based on electric power. An electrical refrigerator 400 watt power operates 8 hours per day. What is the cost of energy to operate it for 30 days at rupees 3 per kilowatt hour? So now what is this 400 watt? It is the power P. And what is this 8 hours per day? It is the duration which the appliance is being used. For how many days it is used? 30 days. So as you can see, first we need to calculate how much energy it is consuming, because electrical power is the energy consumed. So 400 watt is the energy consumed. It is used for 8 hours per day. For 30 days it is used. So we will get the total energy consumed is equal to 96,000 watt hour. That means 96 kilowatt hour. 1000 means kilo. So as you can see, watt and hour we have multiplied. So that is the unit watt hour. So 1 unit costs, in the problem they have given rupees 3. So the total cost of 96 kilowatt hour is 96 into 3, that is 288 rupees. So children, here you are able to see how the electrical bill is calculated at our homes for domestic uses. So children, here is a question: why is the electrical power of each type of electrical appliance different? Example, electrical power of electrical heater is 1500 watts and fan is around 100 watts. Yes, I am sure you have got the right answer. It is because the total energy consumed by different appliance is different, right? And also they are made up of different material which has different resistances. So therefore, if you compare a fan with a electrical heater, you will see that fan is a lower power electrical appliances because it uses lesser amount of electrical energy. So its electrical power is less. And whereas the electrical heater or electrical iron box, it utilizes huge amount of electrical energy, therefore its electrical power is very high. So children, based on what you have learned, try to solve these questions. Take down: why is the tungsten used almost exclusively for filament of electric lamps? Explain. Already we saw it. Why is the tungsten used almost exclusively for filament of electrical lamps? Explain. Second question: an electrical motor takes 5 ampere of a 220 volt line. Determine the power of the motor and the energy consumed in 2 hours. So children, try to solve more number of problems and more number of questions from the exercise also, and try to read the textbook as much as possible and improve your knowledge and get your doubts clarified with your teachers as well. Thank you for watching.